This is the video for Friday, February 19th. In your own words, how is the elasticity of supply different from the elasticity of demand? If you remember, yesterday we talked about that and how with the elasticity of supply, we have these three questions right here. Can the purchase be delayed? Are adequate substitutes available? And does the purchase use a large portion of your income? And how that's how you determine elasticity of supply. If you have a yes answer to these three questions, then it is likely to be elastic. If you have a no, it's likely to be inelastic. Well, demand uses those three questions, but supply does not. Supply is only based on how easy is it for your firm to change the way it does its business and adjust to a new change in price. If it's able to adjust easily to a change in price, then it would have elastic supply, and if not, it would have inelastic supply. So rewrite that in your own words to answer the bell work. Pause the video so that you can do that, and we'll resume when you're done. Okay, so today we're talking about the theory of production. The theory of production is the relationship between the factors of production and the output of goods and services. In other words, it is going to be the relationship between the factors of production, land, labor, and capital, and how we're able to produce more goods and services when we change some of the factors of production. As we increase factors of production, are we able to increase our output of goods and services? And how much are we able to increase our output of goods and services? So this is going to be done in a couple different ways. One with the short run and the long run. The short run and long run, they're not just phrases that have no defined set of time, right? What it actually means, the short run is a period of production that allows producers to change only the amount of the variable input called labor. So let's say that I have a factory. In my factory is a capital good, right? Remember, capital is all the tools and equipment that is used to produce goods and services. So my factory, my machines and tools inside the factory, that's all capital. And the raw materials that I have, that is land. The labor is the people who work at the factory. So if we're talking about a short run change, then we're talking about only changing the labor. I still have the one factory. I have all the same machines and tools and equipment, and I have all the same land, natural resources to create these things. I have all the same things there, but the only difference is that I'm changing the labor. So as I hire new workers, I'm able to increase the production. As I fire workers, I decrease the production. That would be the short run. And then the long run, now we're talking about the period of production long enough for producers to adjust the quantities of all their resources, including capital. So in the short run, all we're doing is hiring new workers for our factory. In the long run, we might be building new factories, buying new machines, buying new land, the natural resources that we use. It's not just the labor, it's all the factors of production. And so once we've made enough money, we can buy that second factory. Now we're talking about the theory of production in the long run. Today, we're focused only on the theory of production in the short run. In other words, as we hire more workers, how can we increase the amount of production that we have? And to what extent does hiring new workers increase the production that we have? So the production function is a schedule that relates to the changes in output at different amounts of a single input. So what this is going to be, this is just going to be a chart. And we're going to chart our different things. We're going to say, as we add new workers, this is how many new things we're going to get. This is how much more we're going to be able to produce as we add more workers. Okay, so here's going to be a chart that's going to be a production schedule. It's the same as the production function. It's the same thing. And we're going to see in column 1 the number of workers. As we increase our number of workers on this left-hand column, you're going to notice that the total product is going to rise, right? With 0 workers, you make 0 of your total product. With the first worker, you make 7 of your product. And with the second worker, you make 20 of your product. The third, you make 38. And so you'll notice that as column A goes up, at least for a while, column B goes up as well. The total number of workers, the total product goes up as well. Now, there's another concept here called marginal products. And this marginal product is basically how much new input is this next worker going to provide. So when you hire the first worker and he gives you 7 products that you didn't have before, that worker number 1 has a marginal product of 7. The second worker is going to have a marginal product of 13 because the first worker gives you 7, and then the first 2 workers combined give you 20, and so hiring the second worker gives you 13. The third worker gives you 38, and so total, and so that third worker gives you 18 by himself. And it's not that the second worker is a better worker than the first worker, or that the third is better than the first or the second. It's that as we keep adding new workers, we are going to continue to become more efficient and allow for specialization. When worker number 1 needs to make 7 of the product all by him or herself, that's much less efficient than if the 2 workers can split the work together, and at the end of the day, you come out with 20. Or if 3 workers can split it and you come out with 38. So we're going to notice that for a while, these numbers are going to go up. Each new worker is going to give you considerably more than the worker before, and then they're going to start going down even while the total product is continuing to rise. I'm going to tell you why that is on the next slide, but this product production function is basically going to be a graph of that. We're going to be able to plot all of our points at number of workers going here from 0 to 13, and total product going up as well. And number of workers is going to be 0 and 0. There it is. And then once we get to 1 worker, we have 7 product. At 2 workers, we have 20. At 3 workers, we have 38, and so on and so on. And we're going to continue to draw this line. Now, the law of variable production states that in the short run, which is when you're only changing, remember the input called labor, you're only changing your labor, your land and your capital stay the same. In the short run, output will change as one input is varied while others are held constant. So if we have the same land and capital and we increase or decrease our labor, we're going to change our output. And generally speaking, as you increase labor, you increase output, and you decrease labor, you decrease output. There becomes a point where that's no longer true. But for the most part, if we have a factory and it has 10 workers, if we hire the 11th worker, we're going to get more production than we had before. That is the law of variable proportions. For example, if you are preparing a meal, you know that a little bit of salt will make the food taste better. A bit more salt may make it tastier still, yet at some point, too much salt will ruin the meal. I just imagine dumping an entire salt shaker on your fries. As the amount of input, which is salt, varies, so does the output, which is quality of the meal. It matters how much salt you put on it, but as you change the salt, every time you change the salt input, it changes the quality of the meal. That is the same thing as the law of variable proportions. As you change the people who are working for you, as you hire or fire workers, you're going to change your production. That's all the law of variable proportions means. The law will help us answer the question, how is output of a final product affected as more units of one variable input or resources are added, or to a fixed amount or of another resource? So in other words, as we add more and more people or take away less and less people, we are going to change the amount of things we produce, so long as our other factors, our land and our capital, remain the same. So the diminishing returns is the amount, the output decreases at a diminishing rate as more units of a variable input are added. If we go back real quick to this, you will notice that at some point right here, this column stops going up. If you remember this column basically said that as we add another person, this is how much that person adds. So our first person adds 7, our second person adds 13, our third person adds 18, right? Because going from 7 total to 20 total, the first person adds 7, the second person adds 13 to go from 7 total to 20 total. At a certain point, this number will start going down. At a certain point, adding that 6th person will no longer be getting those those big returns, right? We're going to start to have marginal return where the sixth person doesn't add as much as the fifth person did. The sixth person is still adding, but not necessarily as much as the fifth person did. The fifth person added 28, the sixth person only added 20. And so this number, the total product, is still going up. You can see it's still going up here, but it's not going up as steeply because the sixth person didn't add as many as the fifth person. And the seventh person only adds 19, which is not as much as the sixth person. And the eighth person only adds 9, which is not nearly as much as the seventh person, and so on and so on, okay? So that is diminishing return. The output increases at a diminishing rate as more units of a variable input are added. Okay, that is right here when we enter stage 2. Stages of production. These are the stages. We haven't quite talked about this yet, but even back on our last chart, you'll notice that we're broken into stage 1, stage 2, and stage 3. But the stages of production are based on the way marginal product changes at the variable input. As the variable input, labor is changed as well. So we have 3 stages of production. The first stage, stage 1 here in your notes, is increasing return. As long as each new worker hired contributes more to the total output than the worker before, the total output rises at an increasingly faster rate. Because marginal output increases by a larger amount every time a new worker is added, stage 1 is known as the stage of increasing returns. So when we look back at our chart here, our chart says that as each worker is added, this number continues to go up. Okay, so from 7 to 13 to 18 to 24, this number continues to go up. This is the new amount of input that can be attributed just to the most recent worker you hired. So the fourth worker adds 24 units, the fifth worker adds 28 units. That is going to be stage 1. Stage 2 is going to be right in here. Once this number, the marginal product, starts to dip, the fifth worker adds 28, the sixth worker adds 20. Therefore, you know you are in stage 2. And stage 2 is the stage of diminishing returns. The total production keeps growing, right? We make more at this place than at this place, but maybe not at the same rate. It is growing by smaller amounts. This worker right here, which in this graph is the fourth worker, I don't know, the fourth worker, as this continues to grow, no, that's to be, let's see, first, second, third, fourth, fifth worker. So this fifth worker is going to be more productive than this sixth worker. Once we get to that sixth worker, that person becomes less productive. Machines may replace workers, and rates of increase in total production are beginning to slow down. And the reason that we have such a fast increase here is, and the reason that the second worker is at 20 while the first worker is only at 7, the reason that happens is because we can allow for specialization. So we have specialization where instead of the first person making everything by themselves, the first person and the second person split the work, and they work together, and they grow more and more and more. And this would allow for specialization. It would allow for assembly lines. But then at a certain point, adding another person starts to just become, maybe there's too many people, too many cooks in the kitchen. There's less specialization. Yes, that this person is able to continue to produce more than the person produce more as a whole. We continue to go up, but proportionally, this person is less valuable to you than that person. Okay, and so maybe at this point, it's time to start hiring machines. And then negative returns, there becomes a point where there's too many people, too many cooks in the kitchen, if you will. In stage 3, the firm has hired too many people, and marginal product becomes negative, and total output decreases. So if we go back to our thing here, we actually make more of our product at 10 people than at 11. Notice this 11th person now becomes too many people, and this 12th person is too many people, has a negative 10. And so it's actually going to be a dip here in stage 3 in our total returns. And so that third stage is now there's absolutely too many people, and you certainly do not want to be there. And here's a good example. This person says, I don't understand it. 2 workers can make twice as much product as 1 worker, but 2,000 workers aren't making anything. And it sort of starts to make sense if you take this to sort of an extreme. You have so many workers that they're not able to make anything because they're stepping all over each other's toes, right? There's just, at some point, there's too many people that you start to have diminishing, not only diminishing returns, and negative returns. So that is the end of this concept.